Hey everyone, I am PC Specialist, and this is the part 2 of the Let's Learn SQL series. In part 1, we went over things like equal to, and, or, like, between, and so on. I know I haven't really been active in making YouTube videos, although I will be making YouTube videos more actively now. So, in part 2, we're going to be covering relational database structure and joins. So, let's hop into it. So, what databases are they're a way that we can contain our data without redundancy. So, I'm going to explain it a little bit more. And so, if what I'm explaining doesn't make sense, or you need to have a clarification, let me know or comment below. Any feedback you give me is always helpful. That way I can always make improvements on my videos. Um, so let me get this. All right. So sorry about that. So let's say that I have two tables. So basically, what a table is it holds within it the data relative to what the name of your table is. And I'll explain that in a second. So let's just say I have two tables. I got one here and I have one here. Ignore this little box. So I'm going to write some names of my tables. One table is going to be called the person table, and I'm sorry, not person. This is going to be called the student table, and this table over here is going to be called the class table. So what the student table is going to contain is it's going to contain attributes. What attributes are they're a way to describe a student. So what that means is things a student has, right? How can we describe a student? Well, we can describe a student by their name, right? So their name is, let me say their name. So a student also has an address. A student could have a height. Let's see, we want to capture that. A student could have, let's see, a birthday. So birth date, and on we can have attributes of a student. And for a class, I really should have made this to, actually I can just widen this. Genius. Not really, but so for class, ways we can describe a class is going to be the name of our class. So whether it's going to be SQL server or something like that. Another way we can describe a class is by the room number. So I'm just going to put room number. Maybe another way we can describe a class is maybe by the location of the class. So maybe it's in a particular location, and then within that location there's a room. So how it works is that we have our tables, and then these two tables relate to each other. And the way they do that is because we have IDs. So what IDs do is that IDs do a couple things. The one that initially we're going to learn about is the easiest, I think, to understand. That's going to be called a primary key. So what a primary key does is it uniquely identifies each and every item within your table. So if we think of a student, right? What could we do to uniquely identify every single student? Well, I'm sure that every student should have a student ID. So if we add that to our table, so if I add student ID, this field here, student ID, is called a primary key. So I'm just going to put in parentheses PK. So what your primary key does is it's going to uniquely identify each and every row within our table. So an example of that would be if I have student ID 1, and if I have a name of Martin, and I have a address of 123 Main Street, so on and so forth, and if I add another person, and this ID is 2, this person's name is John and they have an address, then I have another ID of 3, I have a name, I have an address. This ID or these IDs can never repeat themselves. They always have to be unique across the board. So let me erase this here. The same thing is going to go for your class. Your class is also going to need to have a primary key in it. I like to name the primary keys with the name of the table plus ID added to it. Just like we named the primary key on the student table student ID, much like that, we're going to name the primary key on the class table class ID, and in parentheses I'm going to put PK. So we have our class ID in the class table. So what that would look like, for example, is 1, and we have our class name like SQL, room number is 3, and location, let's say location is going to be Galloway. Alright, so here's a location, and we have another and we have within here another class that's okay. It's called SQL2. Yes, I know, very creative. And then this room number is 4, and let's say that this is going to be in, I don't know, New Jersey, let's say. So this class ID again is going to uniquely identify every single class we have in there. So let me just erase this here. Alright, so we now know how primary keys are used and what they're used for. But we still don't know how to relate these two things together. So between these two tables, there is a relationship. That relationship is that one class can contain a multiple students. That's our relationship. So we need to capture that without having redundancy within our data. What I mean by that is that I could just add within this table student name, like I could make an attribute that's for student name, and then put in here the student address right next to it, height, birth date, and then just contain everything all together. The problem with that is that every time we create a class, we're going to have information relative to the student entered in again, the same thing over and over and over again, if it's a class that's made on that particular student. What I mean by that is if I have one student, let's say that their name is John, and they take 3 classes in one semester. So let's say 3 classes. My handwriting is really bad, I'm sorry. In one semester. What that would mean is I would have John, John, and John listed 3 times, then I'd have this information here. Well, that's not really useful to us. It causes redundancy in data. It makes things larger than it should be. It overcomplicates things. When you go to update something, you have to update everything. So there's really a lot of issues with this. So let me see if I can control Z all back this stuff here. So the better way of doing it is, let me erase my student name stuff here. Sorry, bear with me. Now I just erased half my table. So the better way of doing this is we can add something to the class table that was called a foreign key. So what the foreign key is it's a primary key that is taken from one table and added to another table to specify a relationship. So again, a foreign key is a primary key taken from one table and added to another table to specify a relationship. So remember how I said in the beginning that one class can contain multiple students? Well, we need to have a way to capture that. So the way we do that is in this class table, we create a column, and these are called columns or they're called attributes. Those terms are used. Those terms are used interchangeably. Um, so I can add in here the student ID, and I just like to put next to here FK for foreign key. So I took, let me do this in a different color. I took this student ID here and I added it here. So now I'm able to relate this table here to that one there. So what that looks like in the database is if I have a student, and let's go with so their ID is 1 and their name is Martin, and their address is, I'm just gonna put a blank space. So let's say I had all this information already entered, and then I have a class here. So I have class number 1 and I have a name, it's called SQL, I have a room number, location, everything else. Then for my student ID, how do I refer to Martin then? Well, the student ID here in this table is 1. So for this student ID, I would just put 1. Well, what if then Martin wants to take another class? So we have our second ID of our class table because remember, primary keys have to be unique. So this is called, so we have another class that's called SQL, SQL2. It's not an L, sorry. So again, we refer to the student ID, which is 1. One thing about this here, the student ID, this part here, the foreign key, that can be duplicated. And the reason being is because it's not a primary key. So primary keys cannot be duplicated. Foreign keys are allowed to be. They are optional, and it's okay if they are. So this is just a example that I thought would be helpful. Again, if you wanted to ask anything, if it's unclear, if there's anything I can help answer, um, just add some comments below and I can help to clarify those. So let's hop into the code and let's see what this actually looks like. Alright, so let's create a new window. So file, new, new project, new query, here we go. Alright, so there is one table I like to grab information from, and that's called, let's see, let me change my database here, sorry, 2012. So it's called select star from production dot transaction history. So transaction history has within here a really good information to do joins with. So everything that I was explaining alludes to joins. So what joins are they're a way that we can have multiple tables to join together to help to answer questions that we need to have answered. So we have our table here and we have transaction ID. So this transaction ID is the primary key of this table, and then we have a couple other keys, these three here, which are called foreign keys that we just learned about. So what we're going to do is we're going to find the table that this here relates to. I know that that table is called select star from production dot product. And by the way, I don't have anything here written down at all. So as I am developing, if I make mistakes and stuff, this is how I actually develop. So really, it's almost like you're developing here at the same time I am, and you're learning at the same time with me. Just wanted to clear that up, just in case I mess up. Um, I'm doing this all like out of my head. So we have this production dot product table, which has in here a product ID. And in production dot transaction history, we have a product ID. So these two tables relate to each other on this column. So what we want to do is we want to join these two tables together on the product ID. So for the inner join, what that means is I'm going to erase all this because I think you all have it. If I draw two circles like this, right? This part in the middle, I'll make this pink. This part in the middle is called the inner join part. What these two tables have together, and it would probably help if I get my brush tool and I put, let me go back to my tables, transaction history and product. So this here is trans history, and this here is product. And this space is what these two have in common relative to product, PRODCTID. So when we join these two together, we're going to join these two on the product ID. So let's go back to our code here. In part one, I explained about aliases. Aliases here are going to be extremely helpful. I'll show you all why in just a second. So we want to take from this table a product ID, join that to this table the product ID. So what we do is we're going to start out with this table. It doesn't matter which one you start out with. I'm just choosing this one here. So we're going to alias this table as P. And then we're going to say inner join. So this is just the beginning of our join. It says, all right, you want me to join something. What table do you want me to join to? Well, I'd like you to join to production.transaction history table. And then I'm going to alias this one as th. Then you say on. So what this on says, it says, all right, great. I have the table that you want me to join to. That's great. But what columns now do you want me to join? All right. So I want you to join P. So P refers to this product table here. And we said that they have the product ID in there. And that is going to be equal to the transaction history, in this case th dot product ID. So just to recap, what we did was we just did this chunk of code here, and then we alias this table as P. Then we said inner join to the table that we want to join to, and then we alias that table as th. Then we said on, which is going to specify how we want to join these things. And this part here defines how exactly we're doing it. So I'm going to run this code here, and it might take a couple seconds to run. So now I have all my data all together from these two tables. So let's see what information we can extract out here. I'm not sure what the what the accuracy is of his data. I don't know what it is, so I'm just going to make up things as I go along. So let's see what the product table has in it. So color sounds cool. All right, and let's see, with name would be good. And product table also has a weight sounds cool too. And list price sounds good. And there's another price in here too. List price. Okay, so that should be good there. All right, so this is everything from our product table we have. Nothing too special there. But we can also put information from our transaction history table in here too. So transaction history has in here actual costs. That's nice. And we have the quantity. That'll probably be good. And what else do we have in here? Let's put in here transaction type. I'm not sure what that is. So we'll just take a look at this data. We'll see what we get. So W is not really helpful to us. WSP. Alright, so I'm not sure what this is, so just so it's not confusing, I'm just going to remove that. I'm going to stick to these columns I had initially. Run this code, and we have our color, our name, weight, and list price. That is from our product table, and these two columns here are from our transaction history table. Alright, so why is this so good? Alright, so let's say that our manager came to us. Then they said, hey, we bought products, and then those product prices that we bought, which is going to be this, which is going to be what's going to be actual cost. We want to know how much money we made. Well, we know what we paid for it. Let's say hypothetically actual cost is what we paid for it, and then list price is how much we were able then to sell that product for. Well, these are located in two different tables. So actual cost is located in the transaction history table, and list price is located in the product table. I know that in here that's not that's not exactly what this part here um, depicts, but let's just make pretend that's how it works. So you say, okay, so so now we're going to write the code to do that. So I'm going to put a comma here after the quantity. So to do that, we take what the list price is and we subtract that from the actual cost. So we're going to write that exactly as I said it. So p.listPrice minus th.actual cost. So let's run this and we'll see what happens. So your manager is now looking at this, then so they're looking at, then so they say no column name. I don't know what that means. Did we lose money? Did we get money? What is this? So this is why aliases are really important. You're able to take a column and you're able to rename it whatever you want it to be descriptive. So in this case, I want to say as profit, because this is how much money we made. If you run this, hand this off to your manager, they'd be like, oh wow, we made on this product $2,200, and we made on this one $91. That's great. So really aliases are here to help us for clarity, and they're also to make your code a lot cleaner too. So just to show you what would happen if we weren't to use aliases. So let's say that I didn't have here as p. Then everywhere we have p, I'd have to put production.product. So production.product.color, and you can already see why aliases are so powerful and so good to use, because they make the code a lot easier to read, and then they also help you to develop faster too. And there's a whole bunch of a whole bunch of other reasons why they're really helpful. So basically, here's your join here, and we created this code to give us what our profit is. So that's awesome. So now we know how to do joins, and we can add up things, and we can subtract things. So let's do something else here. So there is a table in here that's called information schema dot tables. And if you don't know what that is, that's okay. I'm going to explain it. What this is it's going to show us all of our tables um, in this database that we have available to us. So let's scroll down and let me find one that should be good. Let's do human resources employee. That sounds interesting. So I'm going to select star from human resources employee. So we have here our table schema. We have here our name. So imagine a schema as being a container, and then the tables are contained within a schema. That's basically how it is. So it's really a container within a container. So let's run this code here. Select star from human resources employee. Let's run that, and we see business entity ID, birthday, job title. I think that we used this table last time in part 1. So this one, not sure if we can do a join. I'm pretty sure there's another table here we can use for join. This is employee, employee department history. This should be good. So we want to see which employees have been with what department, and then give me the history of that. So there's a table that I see that's called human resources employee department history. Let's see what's in here. So we have business entity ID, department ID, shift ID. So business entity ID here is the primary key, and department ID and the shift ID are the two foreign keys in this table. So let's join these two together. Let's see. I may need to have one more table here. Select star from human resources department. Okay. So I'm going to join together these three tables together. So I'm just going to comment these out here. Alright, so I'm going to start out with the employee table. And again, it doesn't matter which table you start out with. The results are going to be the same. So I'll just start out with the human resources employee table. I'm going to alias that as E. So as E. You don't have to put as, I just like to. The same thing when you're doing joins. You don't have to say inner join. You can just put you can just erase inner and then just put join. That works too. I just like to put inner just because it just helps with just the clarity of it. So we're going to say inner join, then we're going to say what table do we want to join to next. Well, we want to join to human resources employee department history as EDH. How I name my aliases is, if you haven't noticed already, each of the capital letters after what the schema is, that's what I put as my alias. So in this case, E is capital, so I put E, and the E, the D, and the H are capital, so I do EDH as my alias. So the next thing we need to do is we need to say on. So we have one table joined to another table. How do we do that? On which columns? So we're going to say E dot business entity ID equals to EDH dot business entity ID. Let's run this code and see what we got going on. So we see that the CEO is in department number 16, which we're not sure what 16 yet is, because 16 is not helpful to us. It's just an ID, so we don't know what that is. We have to join to it. But we have at least what the start date of the employee is. Sorry, I was having a brain fart. So we have the start date of the employee, the hire date. We have all kinds of useful information here. What their shift is. Really good information here. So let's do a inner join to human resources dot department, and this is gonna be as D on. All right. So here's where it gets a little bit tricky, right? So now we're joining to three tables, right? Do I need to put like a business entity ID equals to this ID and that ID? Well, let's just take this. A little bit at a time. We know from here up the code works, right? Now we're trying to join to human resources dot department. Well, let's think about this for a second. What table has what we need? Well, if we look at this employee department history, if we run that, we have in here department ID. Interesting. So let's run the select star from human resources department. That also has department ID. So does that mean that we can just join those two tables together? That's exactly what that means. So we're going to join to EDH, so EDH dot department ID equals to D dot department ID. So because we've already joined to employee on this table, we don't have to join to it anymore on this table. So let's run this code here. Alright, so we got the CEO here, and we know that she's in department 16. We have no idea what it is yet. So if we scroll over, we see that that department is the executive department. Now that really helps us. So the group name is called Executive, General, and Admin. So that's really interesting. That really helps us. Not sure why it helps us yet, but it's still going to be extremely useful information. So let's say that I needed to know what the hours of my employees are. So looking at this, I see shift ID is 1. So 1, 3, 2, 1. I have no idea what times they work. So again, we need to do our join. So kind of how I knew how to join these tables together is that these columns, they give us hints. So what the hint is that if you have a column like this, right, for shift ID, so this is shift ID. Make pretend that this ID here doesn't exist. Just look at shift. So what you're going to do is you're going to look for a table that's called shift in the human resources schema. If it's there, then I think more than likely that's what you would join with. So let's see if there is something called shift. So human resources dot shift. Ah, look at that. So we have that. So that's kind of the giveaway to join your tables and to how to know how to join things together. So let's say inner join human resources dot shift as S on. So remember, department has the shift ID in it, which is what we need. So oh wait, I'm sorry. I think it's EDH dot shift ID. Sorry about that. So EDH, which is employee department history, has the shift ID, and the shift table also has shift ID. So let's run this. So we get all kinds of data here. So we have the CEO of the company, who we know is in the department that's called executive. We know when she was hired, and we also know what shift she works. So she works in the day shift. All right, so now we're going to narrow down our data just a little bit. So let's say that I want to see all of the people who work in the engineering department who work in the day shift. So we have our where clause here, right? So we learned about this already. So where name equals to ENGINE, engineering. All right, so let's run this code. See what happens. So ambiguous column name. So what did we do wrong here? Let's let's look at this again, and let's scroll over to the right, and we see our name column is executive. So ambiguous means that we didn't hand to SQL Server enough information to run the query. So maybe there's another column that's called the same name. Well, let's see. Name. Group name. I don't see another column here that's called name. Oh, yes I do, right here. So there are these two columns here that are called name. So really, what SQL Server says is, what column do you want me to search? Do you want me to search this one here, which is from our department table? Or do you want me to search this name column in the shift table? Well, I want you to search the one in the department. So we're going to put D dot. And then SQL Server says, oh, okay, no problem. So it runs that code, and then it's going to give me all of the engineers. So if I scroll over to the right, I see all of my engineers. So it just so happens that all of the engineers, they work here in the day shift. Let's put in here one more query before we wrap up the video. Alright, so let's do something a little bit tougher. Let's run this again. Let's see. Birthday, hire date. Alright, so let's say that we want to see all of the people that were hired in the year 2002. So there's going to be a lot of ways we can do this. I'm going to show you the way I prefer to do it. So we begin with our where and hire date. So whenever we have joins, so whenever we add a where clause, it's always going to be a really good practice to always put what the alias of the column that you're trying to filter on is. So for hire date, I'm pretty sure hire date is in the employee table. So I put e.hire date, and then I'm going to say between 1/1/ I think I said 20 or 2002. So between January 1st, 2002 and December 31st, 2012. So if I run this code, oh, I'm sorry, I said 2012. I meant to say 2002. I'm sorry about that. So whenever I develop in real time, mistakes happen like that. So we see all of our employees that were hired in 2012. There's going to be within here other ways that we can do it. I'll explain in the later videos why this way is the better way over doing it other ways. Until then, if you like this video, a, a subscribe, comment, or give me a thumbs up. Let me know what you liked, or what you didn't like, anything that you wanted me to cover that I didn't. Let me know. That way, I'll be able to add things into the videos and also to make improvements too. Well, thanks again, and so until next time.